All right, guys, section 2.1, arithmetic and geometric sequences. We'll just have two parts to this section. So just to start things off, we're going to define what a sequence is. A sequence is a list of values in a pattern. Okay, so it doesn't really matter what the pattern is, it just matters that it has a pattern. So for example, you might have 1, 4, 9, 16, 25. These should look familiar because they're all of our perfect squares, or at least the beginning of the perfect squares, right? So the next one will be 36 and 49, etc. It doesn't have to do anything with, it doesn't always have to be perfect squares, but it just has to be a list of values that are in a pattern, okay? Now, we're going to focus in on two types of sequences, what's known as arithmetic sequences and geometric sequences. Arithmetic sequences have what we refer to as a common difference. All right, so let me show you an example of what that would look like. So if our sequence is 8 and then 8.5 and then 9 and 9.5, well, we're adding each time, we're adding 0.5 from one number to the next, adding 0.5. So the difference from one value to the next is just 0.5. That's our common difference. Or even if it was subtraction, right? For subtracting 3 and then subtracting 3 and then subtracting 3, our difference is just -3 here. All right, so that's again, all arithmetic sequences, we're either adding the same number over and over or subtracting the same number over and over. Geometric sequences have what's referred to as a common ratio, and it always needs to be written as multiplication, even if it looks like division. All right, so let's talk about this one. So we have a geometric sequence right here. So 2, -4, 8, -16. So from one value to the next, the pattern here is we're multiplying by a -2. Right, so if you multiply by -2, you get that one. If you multiply by another -2, you get 8. If you multiply by another -2, you get 16. And so the ratio here is what we're multiplying by, which is -2. Now, this next sequence that we have right here, it looks like we're dividing, right? We're dividing by 3, dividing by 3. Really what we're multiplying by, though, is the reciprocal of what we would divide by. So dividing by 3 is the same thing as multiplying by 1/3. Multiplying by 1/3. Multiply by 1/3. And so that's our common ratio, just 1/3. If you ever have a difficult time seeing what the ratio is, you can just divide consecutive terms. It doesn't matter which two. So you could divide the second term by the first term. And if we were to divide both those by 9, we would get 1/3. Or you could divide the third by the second. Or the easiest one would be to divide the fourth term by the third term. Right? If you divide the fourth by the third, that is our ratio, right? We're just dividing 1 by 3. All right, so each of these sequences have different formulas for what's referred to as the nth term of the sequence. The nth term could be any term of the sequence. So for arithmetic, we're going to use A's, and for geometric, we're going to use G's. So for arithmetic sequences, it says that a sub n, which is just the nth term of the sequence, is equal to a sub k, what's called the kth term of the sequence. I know it's kind of weird, but it's really just whatever term we're going to choose from the sequence, or plus the common difference, and then multiplied by n minus k, and that's going to be dependent on what these two values, where they're coming from in our sequence. For geometric sequences, to get the nth term, we take the kth term and we multiply it with the common ratio to the n minus k. All right, so I know those formulas look a little bit confusing, so let's see in a question how we would use those. All right, so write a formula for this sequence, then use the formula to find the 20th term of the sequence. So first off, we have to determine, is this arithmetic or is it geometric? Well, from one term to the next, we're just adding 2. And so this is an arithmetic sequence. So because this is arithmetic, we're going to use the formula that says a sub n equals a sub k plus d times n minus k. Now, I'm going to leave, initially, I'm going to leave a sub n alone and n alone as I'm making the equation. Eventually, we're going to use those things to find the 20th term. But for now, we're just going to leave those alone. So we actually get to choose what term we start with. So if we want to start with the first term, this is a sub 1. This is a sub 2. We could use any of them. I usually just start with the first term. So a sub n is going to equal, we're choosing k to be 1, so it's going to be the first term. So the first term is negative 7, plus we're adding 2 each time, so the difference is 2. And then multiplied by n minus. Because we chose the first term, that means k is 1. So n minus 1. So this equation works. If I had chosen the second term right here, it would just say this. A sub n equals negative 5 plus 2 times n minus 2. All right, the second term would go here, and because we're using the second term, we'd put a 2 in for k. All right, so these are actually the same formula. And if we were to distribute and combine like terms, you would actually see they simplify into the same formula. Now, I'm going to use the first one. I just want to show you guys, you can come up with, there's more than one option for the formulas here. And we're going to use this to find the 20th term of the sequence. So I'm just going to replace both ends with a 20. So this now says the 20th term. Well, it's going to equal negative 7 plus 2 times 20 minus 1. Now, order of operations, we want to do what's in the parentheses first. So subtract first to get 19. Do not add those two together. We multiply. Once we subtract those to get 19, we want to multiply the 2 and the 19 together, and then we'll add it to negative 7. So that's negative 7 plus 38. And if we add those together, we get 31. All right, so that's our 20th term. Now, you may be thinking, why wouldn't we just list out 20 terms? And that is an option. But if I asked you for the 200th term instead of the 20th term, you probably are not going to want to list out 200 terms. Okay, so that really is when, as that number gets bigger, where we for sure want to use this formula to find the 20th term here, or the 200th term, or whatever it may be. All right, next question. Write a formula for the following, then use the formula to find the 6th term. So we already have 4. So it would be super easy to just keep going and list out the 6th term. But again, I want to show you guys, for if those numbers get bigger, how we would do this. If it was more, further on down the line, and we don't want to have to list out a bunch of terms. All right, so first off, we are dividing by 2 from one term to the next, or multiplying by a half, times a half, times a half, times a half. Again, if you don't see that, if you are like, how am I getting the 1/2? Just divide the second term by the first term, and then simplify. The zeros cancel. 4 over 8, you divide them both by 4, it's 1/2. All right, or divide 20 by 40 or 10 by 20. All right, so that's our common ratio. So we have to use the formula for the geometric sequence. All right, so just like the last one, we're going to start off with n being n. We're not going to substitute anything for that at the beginning. But we get to choose what term to pick here. So I usually pick the first term. All right, so if I pick the first term, this is g sub 1, which is 80. So I can replace g sub k with 80. We can replace r with what we're multiplying by, which is 1/2. N is just n for now. And then I'm just going to put this in parentheses to make it a little bit easier to see something. And then k is whatever term we picked. I chose the first term, so k is 1. Now, a very common mistake here is people think we can multiply these together, but this has a different exponent than the 80 does. The 80 is to the first. This is to the n minus 1. So we can't multiply the 80 and the 1/2. All right, so this is our formula. If we want the 6th term of the sequence, well, I would just plug in 6 for n. And so g sub 6 is going to equal 80 times 1/2 to the 6 minus 1. So order of operations, we're going to do what's in the parentheses first. So 6 minus 1 just gives us 5. And then we're going to do the exponent, so 1/2 raised to the 5th. So 1/2 to the 5th is 1/2 times 1/2, 5 times. Well, multiplying the numerators, that's just 1. Multiplying the denominators, 2 to the 5th, so that's 2 times 2 is 4, then 8, then 16, then 32. So 1 over 32. Well, now we've got 80 times 1 over 32. The 80 is being divided by 1, so we multiply the tops, multiply the bottoms, and we get 80 over 32. And then let's see, what are those both divisible by? I think 8 is the biggest one that goes into both. Or is it? Let's start with 8, and then we'll see what happens. So if I divide both by 8, it gives us 10 on top. 8, 16, 24, 32. So that gives us 4 on the bottom. So I should have divided by 16. But now I'm going to divide them both by 2, and I get 5 halves. Okay. Now, that was a lot of unnecessary work if we're only looking for the 6th term, because all you would have had to do is multiply by 1/2 2 more times. So 10 times 1/2 is 5, and that 5 times 1/2 is 5 halves. Right? So we could have gotten there a lot easier, but again, sometimes it will be like the 20th term, the 100th term, right? So it would take a long time to just list all of those out. All right, so that's it for part 1. Stay flawless.